Hello, guys. Welcome back. So, I think we got to these questions last time. Comment if we didn't. I think we got to the. I feel like we did 15 and 16, and we were about to do 17 and 18. If I'm wrong, give me a comment though. I just can't really remember. But yeah, could you guys write your name so I can do the register? Which is here. Right, so you got Ed. Register's still weird. I still can't swipe half of you in. Jake can swipe you in. Molly, you can be swiped in. Grace can be swiped in. The rest of you, I don't have the option to click present, so I'm not sure what's going on with you guys, but something weird. Jasmine, are you there? Don't know. If she's here later, I'll send her in. Yeah, so could you guys comment if I think we're doing these two questions here. I think. I can always go back and look at last time's lesson. I'm going to assume it is those for now, though. We did 15 and 16. Okay, yeah, cool. I did remember correctly. Good. Right, so we're going to start with those two today. I reckon 6 minutes to try and do those. So I'll put the timer on now. I'll make that a bit bigger so you've got some room there. So 6 minutes to try and do those two. Yeah, just to get you guys warmed up. So 6 minutes starting from now. Cool. All right. So these are two kind of different integrals here. First one, a couple ways you can do it. I think the easiest way to do the first one is long division, but you could possibly use substitution for this one as well. I don't know. I've not tried substitution, but I think long division is the easiest way. So we got 9x divided by 3x take 8. So that goes in 3 times. So we get 3x of 9x there, minus 24. So we subtract those, we get 24. So we get 3 plus 24 as the remainder out of 3x take 8. That's what we're trying to integrate. So the 3 is going to turn into 3x, and the rest is going to turn into ln 3x take 8. We want 24 out the front, so we need to times this by 8, I think. Yeah, sounds good. Yeah, that's it. Cool. Oh, we need to put the limits in. 24 and 8. So 3 lots of 24 is a job for the calculator for 72, isn't it? 72, yep. Plus 8 lots of ln 64. Take away 24 plus 8 ln 16. So 72 take 24 gives us 48. Plus 8 ln 16 divided by 64 divided by 16 is 4. So we get that as our final answer. Cool. Right, second one on this list is partial fractions, I believe, because we got the denominator is squared, so we can split that up. So we're going to get a over 3x take 8 all squared plus b over 3x take 8. Do some cross multiplication. So we get a plus b 3x take 8 9x. That x equal 8 over 3. So we get a equals 9 lots of 8 over 3, which is 24. And then we can let x equal 0 to get 24 minus 8b equals 0. So b is 24 over 8, which is 3. So I can make a into 24 up here, b into 3, and then we're good to go. So we're going to integrate both of those bits. So the b term is easy. We're just going to get ln 3x take 8, no changes needed. First term, we're going to rewrite it as 24 3x take 8 to the minus 2. So the power is going to go up 1 to get 3x take 8 to the minus 1. And then we need to work out what we need to do to it. So we want to get 24 out the front. If we differentiated it, we get 3. We get minus 3, so we need a minus 8. And that is our answer. Cool. Hopefully that's right. Not really tricky, but they do make you think because they all kind of look the same and they've all got different methods. All right, next one we're going to do then is so there's 2 more to do here. Question 19 and 20. We've not done these already, actually. No, let's do them again, see what you guys remember. So I'll give you 5 minutes to do those. Please comment your answers, guys. There should be, I don't know if they're integers, but you should be able to write your answers for this one. So I'd like every single one of you. There are 11 of you on the stream. Can you guys comment what your answer to 19 and 20 are? So the clock starts now. If you need any help, ask as well. Elizabeth, yeah, that's not a bad method actually. I don't see why that wouldn't work. As long as you chose u as 9x, that should be definitely a way of doing it. Yeah, I don't think it's much more effort. No, if the order's the same or higher, you have to do long division if you're going to use partial fractions. But you can always try and use partial fractions as long as you actually have, as long as you have more than one term in the denominator. Not more than one term. As long as you have a product of terms in the denominator, you can pretty much all right. As long as you have a product of algebraic terms in the denominator, you can try and use partial fractions. Yeah, and then if it's equal or greater degree on top, you need to use long division first. Ours was less degree though, because 9x is maybe hang on, because it was squared on the bottom and to the power 1 on the top. It was a lesser degree on the top. So that's why we could do it. Cool. All right. Hopefully that was time. Cool. So first one, we did this on Wednesday. Hopefully you remembered it. So to do sine cubed, you split it into sine times sine squared. Then we split the sine squared into 1 minus cos squared. Then we times that out to get sine x minus sine x cos squared x. Sine x integrates to give us minus cos x. And this one, we're going to try cos cubed. So try cos cubed, we're going to need to divide it by 3. And cos integrates to positive sign, so we also need a minus in there as well. So our answer gives us minus cos minus a third cos cubed. We need to put in 0 and pi by 4. So putting pi by 4 in, we get minus cos pi by 4 minus a third cos cubed pi by 4. Remember, cubed means cube the whole thing. So I'm going to put my calculator into radians. Cos pi by 4 is 2 root 2, so minus root 2 over 2. Minus 1/3 root 2 over 2 cubed. Take away cos of 0 I know is 1, so we're going to get take away plus 1 and then plus 1/3. So root 2 over 2 cubed times minus a third gives me minus root 2 over 2 minus root 2 over 12 plus 4/3. So just to fully simplify, I don't think it's going to get much better. We get 4 over 3 minus 7 root 2 over 12. Okay, last one. Learn times x squared. Going to need to use by parts twice. No, we're not. That's rubbish. We're going to need to use it once. So u is ln x. dv dx is x squared. du dx is 1 over x. V is x cubed over 3. uv is x cubed over 3 ln x minus the integral of v du dx, which is x squared over 3, leaving us with x cubed over 3 ln x minus x cubed over 9. And we're going from 1 to 2 this time, so we're going to get 8 over 3 ln 2 minus 8 over 9. Take away. Ln of 1 is 0, so we're just going to get take away minus 1 over 9. So in other words, 8 over 3 ln 2 minus 8 over 9 minus 1/9 is going to be plus 7 over 9. Cool. Would like to see some more comments from you guys though. I haven't had any answers yet. Please comment if you need any help or if you need an extension on time, but you should all be able to write something. So would like to see some more of that on the next question. All right, next up. This is the last page. It'd be nice to get through all these today. How do we do for time? We've got about an hour. Okay, I'm going to set you 9 to do, and I'm going to give you a bit of time for this. I'm going to give you 20 minutes to work through these. Comment when you got an answer. Comment when you get stuck. Message me via Teams if you need some help and feedback. But I would like to see all of you try all of these with some comments and feedback as well. Okay, so I said 20 minutes. Got the first one wrong. Which one? Do you want to send me your workings, Harry, via Classrooms, and we'll go through it there, just so I can set everybody off on these, and then we can see what you did wrong in a message. So timer's on now. Right, how are we getting on, guys? Grace has commented on the first two, but has anyone done any more than that? Or do you need some longer time? Or maybe 9 was a bit ambitious for 20 minutes. There are quite a lot of integrals there. Do you guys want more time, or do you want me to go through the first 3 and then give you a bit longer? Give me some... Talk to me, people, please. All right, we'll try the first. We'll do the first 3, and I might give you guys a little bit longer, depending what your comments say. So, first one. We're going to try raising the power. So we're going to get 4x minus 9 to the power 6. Then we need to think our way through the chain rule. So we'd get 4 out the front, which we don't want. We get 6 out the front, we don't want. So we need to do 1 over 24, as Grace suggested. Good job. Second one, we need to bring this up and call it 5 lots of 4x take 9 to the minus 3. So if we integrate that, we're going to get 4x take 9. Power goes up to minus 2. Now, if we differentiate that, we'd get minus 2 times 4 at the front, so we get minus 8 at the front. Now, we want 5, so we need to divide by minus 8 times by 5, so minus 5/8, 4x minus 9 squared. Cool. So that's that one. Third one. Third one you might look at and go, oh, there's partial fractions. But we can actually do this via recognition, because the bottom would differentiate to give you 8x. We've got 5x, so we can use recognition on this. So we're going to try learn 4x squared minus 9. Which, if we differentiate it, we'd get 8x. Now, we don't want 8x, we want 5x. We need to divide it by 8 times it by 5. So that's what you should get for question 3. Question 4 looks similar to question 3, but we've lost the x. So this time we do need to use partial fractions on this one. So we're going to say it's a over 2x minus 3 plus b 2x plus 3. So we get a 2x plus 3 plus b 2x take 3 equals 5. Probably need. So if we let x equal 3 over 2 and minus 3 over 2. First one, we will get 6a equals 5. So a is 5/6. And for b, we're going to get minus 5/6. So if I add those in, we're going to get get to there. And we want to integrate that. So we're going to get some lens. The first one we'll get what should we say? Should we? There's a few different ways you do this. You could expand the bottom and do it like that, or we could say it's 5/6 learn 2x take 3, and obviously the 2 would come out, so we want to get rid of the 2, so we're going to have 5 over 12 there. Your answers might be different though, depending on whether you multiplied by 6 first. And then the second one will be the same idea, 5/12 learn 2x plus 3, which we could simplify and say is 5/12 of learn 2x minus 3 over 2x plus 3. That's our answer there. Okay, question 4. Oops, what? How have I done that? Question 4. So this one won't factorize on the bottom. So this one we need to. Oh, don't know. This is. Oh, sorry. This is a question. These questions are numbered ridiculously. 1, 2, 3, 4, 4, 5. See, I'm guessing this is 5, and they've actually numbered these badly. So Grace, is this the one that you're stuck on? Yeah, this does look difficult. Ugh. Let's try and work out what we could do for this. By parts won't work. You could bring up the power, but we don't have a 5x out the front, so that's going to be problems. That's going to be a problem as well. Bottom does not factorize. We could try a substitution. I don't know what's going to happen, but yeah, why not? Let's dive in and try a substitution. So I'm going to let u equal all of the bottom. And I don't know if this is going to work. I've got no idea. So du dx is going to be 8x. So dx equals du over 8x. This is going to be very interesting. Yeah, anyway, we'll see what happens. So we're going to get integral of 5 over u du over 8x. 8x, well, we need to rearrange to get x. So u take 9 over 4 squared x. Not very optimistic, but let's keep going with it. So that's, in other words, root u minus 9 over 2. So this is all going to turn into the integral of 10 over 8 1 over u 1 over root take 9 eu. Yeah, this is a tricky question. Is there anything else I can do for this instead? Wondering about trig substitution. Just trying to think it through. No, I don't think trig would help either. Okay, I mean, with this, we could try this by parts now, but it's been an easy way to do this. Use tan. Would tan work? 4 tan squared plus 9. No, the problem is with using trig is you want it to cancel out the bottom and turn it into one term, which I don't think will happen with tan, sine, or cos. Ooh, this is a tough one. Might come back to this because just looking at it now is not really helping. I'll write it down though, and we'll do this on Monday. U is 2x over 3. Looked it up. Why would that help? 2x over 3. Let's try it, see what happens. That is a very specific substitution to use though. Okay, we'll try Molly's suggestion. Don't see how this is going to work, but okay. So du dx is 2/3, so dx equals 3 over 2 du. So yeah, x is going to be 3 over 2 u. So this will become the integral of 5 over 4 lots 3u 2 squared plus 9 times 3 over 2 du. So that becomes 5 over 9 squared plus 9 times by 3 over 2. I don't really see how that is any better than where we started, apart from we have 9 in both terms now. Okay, yeah, no, cool, okay. So we're going to take out a factor of 9 and make it 3 over 18 integral of 5 u squared plus 1. Yeah, that is clever. That's very specific though. But yeah, well found, Molly. Du. Now we can use a trig substitution. We can use tan. So we'll have 3 over 18. Oh, let's take out the 5 as well. Why not? It's going to be 15 over 18. Integral of 1 over u squared plus 1. Going to let u equal tan. So we get, gosh, 2 substitutions this one. Brilliant. But there's no limit, so I'm not fussed. No, maybe I am fussed because we're going to want to turn it back into an x integral at the end. So I'm going to keep the u as 2/3 x there. We're going to need another letter if we're doing this twice. So let's say u equals tan squared p. So du over dp is u is tan, not tan p. So du over dp is sec squared p. So we get 15 over 18 integral 1 over tan squared p plus 1 times by sec squared p dp. 1 over tan squared plus 1 is sec squared, so this becomes the integral of 1 dp, which becomes p. Now, we know p is arctan u. So we get arctan u as our answer, then u is 2/3 x. So our answer is arctan 2/3 x. Quality's bad. Shouldn't be. I think it's just you. I've got a good bit rate and a good stream. I've got 60 FPS here, so I think it's just you, Ollie. But if anyone else has got bad quality, let me know. Yes, arctan 2/3 of x is our answer. There. That was hard. That might be the worst integral I've ever had to do. Ever. No, that's a lie. The worst integral I've had to do in A level. Oh, that's horrible though. Anyway, cool. All right, question 5. How long we got? Half hour. Yeah, we're doing all right today. So question 5. Back to a nice, easy kind of question now, to be honest. Well, I think we're going to want another substitution here. We can bring it up to a negative half power. But because we've got x inside, you're going to get 8x, which isn't going to be much good. Yeah, so substitution for this one. Let's try u as 4x squared plus 9. So we're going to get du dx is 8x. So dx is du over 8x. Yes, this is interesting. These are horrible. So kind of thinking maybe 2/3 x is a good way to go again with that one. Yeah, maybe let's try that. I don't think that one's going to work. So x, u is 2/3 x, du by dx 2/3. So we're going to get 5 over the square root of 4 lots of 3 over 2 all squared plus 9. So you get 5 over root 9 u squared plus 9. So we can make it 5 over 3 root squared plus 1. Then if we do a second substitution, we're going to say u equals, do tan again, tan p. Need to make some space. So we get 5 over 3 root tan squared p plus 1. Tan squared plus 1 is sec squared. Root sec squared is sec, so we get 5 over 3 sec p, which is the same as 5 cos p over 3. Integral of cos is sine, so we get 5 over 3 sine p. Oh, the answer is disgusting for this. So yeah, no wonder it was hard. So sine p, well, u is tan p. Oh dear, so we need to link together sine and tan now. Which is not going to be very easy, to be honest. Yeah, Grace, do you get an answer for this one? I feel like we're going down a rabbit hole. So u is 2/3 x. We've got 5/3 sine p. So I could say that that's 5/3 square root 1 minus cos squared p. Cos squared is 1 over sec squared. So 5/3 square root 1 minus 1 over sec squared p. Sec squared is 1 plus tan squared, so I can say it's 5 over 3 square root 1 minus 1 over 1 plus tan squared p. Yeah, these would never come up. These are disgusting. I think there's probably a further mass method that makes these a lot easier. 5/3 square root 1 minus 1 over 1 plus tan squared is going to be u squared, and u is 2/3 x, so we're going to get 1 plus 2 over 3 x all squared. Oh my god, that was awful. I thought the last one was bad. That's just as disgusting. Check these through because I am doing them quite quickly and on the spot, but the method's probably there, but check your signs and check your coefficients for these ones. Okay, 2 looks a bit easier. They all look easy now in comparison. Do you guys want a bit more time to do 6, 7, and 9? 6, 7, and 9. Great worksheet. I'll give you guys 4 minutes, I reckon, just to try and do those ones. They should be easier. You got some double angle stuff and some trig identities. So 4 minutes starting from now. Cool. All right. So last three. All right. First one. We've got sine times cos, and the angle's the same. So we're going to use the sine double angle. Remember, 2 sine theta cos theta is sine 2 theta. So this is going to turn into sine 4 theta, sine 4x. So sine integrates to minus cos, so minus cos 4x. We need a quarter there. To get minus a quarter cos 4x. Next one, on the bottom, we've got 1 take cos squared. 1 minus cos squared is sine squared. So this will become 2 sine x cos x over sine squared x. We can cancel the sine squared on the sine on the top with the squared on the bottom to get 2 cot x, or to be honest, it's probably easier to leave it as 2 cos x sine x. Integrate that and we get, well, we got function derivative. Cos is differential of sine, so we're going to get 2 ln sine x. That one. And for the last one, again, function derivative. Sine is derivative of cos, well, with a negative. So we're going to try cos to the power 8x. So we'd get an 8 out the front we don't want, so we need to divide by 8, and we'd also get a minus out the front we don't want. So we get minus 1/8 cos x. Cool. All right, so that's the first 9 of these. God, who knows what's going to await us in the next lot. It's 1:15 now. I do want to finish this, but again, doesn't look like we're going to finish it today. There have been a lot of integrals, and they have all been pretty hard though, so it's good stuff. So how many we got left in total? We got 11 left. Okay, well, let's try and get 15 minutes, 11. I might set these as, so I set these as homework. How many is that? 11 to do. 15 minutes now. That gives you a good head start. Yeah, okay, so we'll say 15 minutes now, and I will also give you 10 minutes at the beginning of Tuesday's lecture, but I want them all done by then. So if you guys maybe look at top 3 right now, the middle 5 for homework, and the bottom 3 you can do as a starter on Tuesday to get through all these. So we're going to try these ones now. These ones for homework. These ones on Tuesday. But yeah, could you guys try and get all those done for a starter on Tuesday? If we do 10, 11, 12 now, then can you email the homework, please, because I can't see it very well. Yes, let me just take a photo. I'm going to send it in Teams because Teams has all of you in. Yeah, if you guys want to start that now, we'll see how you go. We might go through the first 3 before the lecture ends, but we only got 15 minutes, so it's quite tight. But yeah, if you guys want to get started on those ones. Where's your group? Cool. Yeah, Ollie, I'm pasting the picture in now. Cool, there you go. All right, so yeah, if you guys want to start that now, question 10 looks easy. Question 11 looks pretty nasty. Cos of 7 sine 4. Ooh, that's not good. Yeah, that one. Oh, it doesn't look great, but yeah, we'll have fun with that on Monday, I think. That one. 12. Sine over cos to the 7. Yeah, that looks alright actually. Just 11 looks hard. 13 looks alright. Bit confusing there. Some of these integrals are horrible. Sorry guys, I have given you some really hard stuff here. 17 looks like nightmare mode. Yeah, I'm sure we'll have fun with these on Tuesday though. So if you want to start them now, that'd be great. Email me if you need any help, but I'll full screen it. I'll still be here, so comment if you need any help right now. But otherwise, have a nice weekend, and I'll see you guys on Tuesday to go through the rest of these integrals. Cheers.